When we talk about AI today, it feels like it just appeared out of nowhere, right? An overnight revolution. But the truth is, we're living in just one single chapter of this really long, dramatic story, one that's full of these incredible highs and some pretty devastating lows. So let's take a look at the wild history of AI's past, starting with its very first exhilarating climb and its first major crash.
So, if you were to chart the journey of artificial intelligence over the last, say, 70 years, it would look a lot like this. It's not a straight line up, it's a cycle of seasons. You get these brilliant, exciting AI springs. That's when there's tons of hype, investment, and big breakthroughs. But almost every time, they've been followed by these brutal AI winters. When all that excitement cools down, the funding disappears, and the whole field just kind of goes into hibernation.
All right, so let's rewind. We're going to go all the way back to the very beginning, the first big boom and bust cycle of AI.
The first AI spring was just bursting with optimism. The very term artificial intelligence was only coined back in the 50s, and we saw these incredible early creations, like Eliza, a chatbot that was designed to act like a psychotherapist. And it was so convincing that its own creator was shocked when his secretary started telling it her deepest, most personal secrets. And then you had Shaky, the first robot that could actually look at its surroundings and figure out what to do next. It really felt like the future was right around the corner. But there was this huge problem hiding just beneath the surface. You see, these early AIs, they worked great in a simple, clean lab. But the real world is messy. It's complicated. The number of possible choices and situations just grows exponentially. It's this thing called a combinatorial explosion. And the computers back then, well, they just couldn't handle it. They were completely overwhelmed.
And that right there was the problem. All of these huge promises that AI was making were just crashing against the hard wall of reality. Big influential reports like the Lighthill report in the UK basically said, hey, none of this stuff has actually delivered what was promised. And just like that, funding was slashed, labs were shut down, and the very first AI winter began to set in.
But, after years out in the cold, a totally new approach started to thaw things out, one that would eventually spark a second spring. So the new idea was called symbolic AI. The thinking was, instead of trying to build this grand general intelligence, what if we just capture human knowledge using symbols and rules? And the most famous version of this was the expert system. The goal was to basically interview a human expert, take all of their knowledge, and painstakingly program it into a computer as a huge set of if-then rules. And this whole rule-based approach was about to have its big moment in the spotlight, a public showdown that would put AI right back on the world stage. The year? 1996. So the stage was set for this legendary battle. The world's greatest chess champion, Garry Kasparov, versus IBM's supercomputer, Deep Blue. Now, Deep Blue wasn't creative, not at all. It was a pure expert system. It just used brute force calculation and this massive library of expert rules to analyze millions of moves every second. And it won. It was the absolute peak for this kind of rule-based AI. But Deep Blue also showed the limits of that approach. It was brittle. It couldn't learn anything new. It couldn't handle anything it hadn't been programmed for. Every single rule had to be hand-coded by a person. And that just wasn't going to work for the real, messy world. This led to another quieter AI winter. So what changed? How did we get from these rigid, manual rules to the AI we have today that can actually learn? Okay, this is probably the most important idea to get. There was a fundamental shift. See, classical programming is all about giving a computer rules and data, and it spits out answers. But machine learning flips that completely on its head. You give the computer the data, and you give it the answers, and the machine figures out the rules all by itself. That's the whole ballgame right there. That's the revolution. And that fundamental shift brings us right up to today's AI spring, which is being driven by a very, very powerful type of machine learning. Okay, let's quickly clear these terms up because you hear them all the time and they get mixed up. Think of it like this. Artificial intelligence is the big, broad goal. Machine learning is one way of getting there. And deep learning, which is the engine behind everything happening today, is a very specialized technique inside of machine learning. So what even is deep learning? The simplest way to think about it is like a series of filters, all layered on top of each other. The first layer might learn to spot really simple things, like edges or colors. The next layer up combines those to recognize shapes, like an eye or a nose. And the layer after that combines those to recognize a whole face. It learns to see the world in these layers of growing complexity, all on its own, just by looking at millions of examples.
But here's the wild part. The basic ideas behind deep learning have been around for decades, mostly collecting dust during another AI winter. So why the sudden explosion in the 2010s? What changed? Well, it wasn't just one thing. It was a perfect storm, a crazy convergence, where three crucial ingredients finally came together at the exact same time. First, we got a tsunami of data. The internet basically digitized a huge chunk of all human knowledge, creating the perfect training library for these systems. Second, we got sheer brute force power. It turned out that GPUs, the computer chips made to make video games look pretty, were perfect for the kind of math these models need. All of a sudden, researchers had affordable supercomputers sitting on their desks. And third, we just got smarter. New algorithms were developed and, this is key, they were shared openly, which let the entire field just skyrocket forward together. And this graph really shows you why all that data was so critical. See, with the older machine learning methods, they'd get better for a while, but then they'd hit a ceiling. You could throw more data at them, but they wouldn't really improve. Deep learning is totally different. Its performance just keeps on climbing and climbing and climbing the more data you feed it. Now, the deep blue moment for this new era was AlphaGo. In 2016, it beat the world's best player at the game of Go, and Go is infinitely more complex and intuitive than chess. Honestly, experts thought this was at least a decade away, maybe more. It proved that a machine could learn strategies so creative that they were beyond what any human had ever thought of. And that brings us to right now. We are clearly in the middle of a massive AI spring. But what happens next? Well, for the first time, the experts seem more divided than ever. On one side, you have some pretty terrifying warnings. The late, great Stephen Hawking believed that a true superintelligence could end up redesigning itself faster and faster, leaving humanity so far behind that it could be the end of us. Then, on the complete other side of the spectrum, you've got incredible optimism. The futurist Ray Kurzweil is famous for predicting that AI will be as smart as a human by the end of this decade and then go on to multiply our civilization's intelligence 1 billion times over by 2045. And of course, there are the massive geopolitical stakes. As Vladimir Putin put it very bluntly, whoever becomes the leader in this sphere will become the ruler of the world. So it's pretty clear that world leaders aren't just seeing this as a cool new technology, they see it as the future of global power. So how do you make sense of all this conflicting information? Well, there's this idea called Amara's Law, and it's a fantastic way to think about it. It basically says we always get swept up in the short-term hype, then we get disappointed when it doesn't immediately change everything. But we almost always fail to see the true revolutionary impact a technology will have in the long run. Which leaves us with the million-dollar question. After this 70-year roller coaster of seasons, of these incredible springs, followed by these harsh, cold winters, is this time finally different? Have we reached AI's eternal summer? Or is the hype just growing so big, so fast, that another winter is right around the corner?